This tutorial will walk you through the steps of balancing out a redox reaction that is occurring in a basic solution. The first step is to separate out the larger equation into its two half reactions. I'm going to start off with one half reaction and walk you through the steps of how we do this knowing that it's taking place in a basic solution, and then I will balance out the second half reaction using the same method. To start off with, I'm going to balance out my non-oxygen, so tellurium has one on each side, that's balanced. And my next step then is to balance out the oxygens. Just like I did with the acidic solutions, you're going to balance out your oxygens by adding water to the opposite side of the equation. On the right-hand side of my equation, I have 3 oxygens. So to the left-hand side, or my reactant side, I'm going to add 3 water molecules. While this does indeed balance out your oxygens, you now have 3 on each side, it has introduced another component, which is our hydrogens. Similar to what we did in the acidic solution, we're going to now add 6 hydrogen ions to the opposite side. Because this is occurring in a basic solution, one of the characteristics of bases is that they remove hydrogen ions from solution, so we would know that there would be a lot of hydroxide ions most likely floating around in that solution. We're going to add the same amount of hydroxide ions to remove those 6 hydrogen ions. Again, we've now introduced hydroxide ions, so we have to add the same amount of hydroxide ions to the reactant side. So we're going to add 6 OH minuses on the reactant side. The kind of cool thing that just happened is what is forming when the hydroxide is reacting with the hydrogen ions is that these are coming together to form water. And we have 6 waters that are being formed. I'm going to change that and add that up to the top just to make this a little bit less messy. Okay, so now my elements should be balanced, and my next step is to balance out my electrons or my charges. On my reactant side, I now have 6 negatives, and on my product side, I have 2 negatives. To balance that out, I'm going to add 4 additional electrons to my product side. A quick check of everything, I have 6 negatives on my left side and a total of 6 electrons or negatives on my right side. Next, we'll move on to do a very similar process for the second half reaction. Again, we're going to start off by balancing out our non-oxygen atoms first. So there's 2 nitrogens on the product side and we're going to need 2 nitrogens on the reactant side. That now changes our reactant number of oxygens to 6, and we only have 4 oxygens on the left-hand side, on the right-hand side, and so we're going to add water to make up for the difference. So we'll add 2 water molecules on this side to make up for the difference. All right, we now have 4 hydrogen atoms on the product side, so we're going to need to add 4 hydrogen ions on the reactant side. And again, whenever we have added hydrogen ions using a basic or under basic conditions, we're going to immediately add hydroxide ions to both sides. Just like in the previous problem, the 4 hydrogen ions, when they come into contact with the 4 hydroxide ions, will then become water. And what we are left with then is a need to balance out the charge. On the left-hand side of the equation, we have an overall charge of 2 negatives, the 2 times -1 in the nitrate ion, and then we have a total of 4 negatives on the product side. To balance that out, we're going to add 2 additional electrons to the reactant side, and our equations then should be balanced. Before we move on to the next step, I'm going to simplify a couple of things in these equations. One is that we're going to cancel out the things in the equations that are similar. And so on the reactant side of our top equation, we have 3 water molecules, and we have 6 on the other side, so we're going to reduce that down to 3. And similarly, on the product side of our second equation, we have 2 water molecules, and we're going to reduce that down so that there's only 2 on the reactant side. Before we can combine the two reactions, we need to make sure that that the electrons in both of them balance. And unfortunately, the ones on the bottom, there's only 2 electrons in comparison to our top. So we are going to have to go through the process of multiplying this bottom equation by 2. Alright, so what I did was I multiplied out that bottom equation by 2 to get 4 electrons plus 4 waters plus 4 NO3 minus 1s plus 2 N2O4s and 8 hydroxide ions. I then, also to clean things up a bit, just brought down my 6 hydroxides plus my tellurium, and then the rest of that equation. Alright, we're now ready to combine these two. Again, when you are combining, if things appear at the opposite sides of the arrow, then they cancel out, they subtract out. So my 4 electrons on both sides will subtract out. I have 3 waters on my product side and 4 waters on my reactant side. So these 3 waters on my product side will cancel out, leaving me with just 1 water on my reactant side. My hydroxides will also cancel out a bit here. I have 6 hydroxides on my reactant side and 8 on this product side. So that'll cancel down to 2. And I believe that's it. So at this point, it's going to be going back and writing this all out in its final form, double checking to make sure that all of my elements are still balanced, and then double checking my charges. Alright, I've finalized the equation at the bottom of the screen, and the last thing we're going to check is to make sure that all of the atoms are balanced, along with all of the charges. Okay, so to start off with, let's take a look at our hydrogens. We have 2 hydrogens on the reactant side and 2 hydrogens on the product side. Our oxygens are a little bit more to count. We have 1 plus 12, so we have 13 oxygens on the reactant side, and we have 8 plus 2, giving us 10, plus 3 more oxygens on our product side. So we have a total of 13 on our product side. Our telluriums balance out 1 and 1, and our nitrogens, we have 4 on the reactant side, 4 on the product side. Last thing we need to check is our charges. We have 4 times a 1 negative, so a negative 4 on our reactant side, and then we have 2 negatives here, plus 2 more negatives there, so a total of negative 4 on the product side. Our reaction should be balanced, and that would be our final balanced equation for this type of reaction.